Hello, everybody. My name is Timothy Tran. I am a solution engineer here at Cloudinary, and I'm here to present some of the latest and greatest Cloudinary features that will help you unleash the full potential of your digital media. We're going to start today's presentation with a quick introduction to Cloudinary. From there, we'll move on to some of the really cool intelligent video features that we have, such as shoppable video, interactive video zoom, and video color mapping. After that, we'll take a look at how Cloudinary has incorporated AI into some of its media management features, such as content-aware cropping and background removal. And lastly, we'll show off some of Cloudinary's 3D capabilities, discussing about Cloudinary's overall goal of simplifying 3D by making 3D as available as 2D, also demonstrating our 3D model viewer and some texture mapping. Cloudinary is a media experience platform that provides a series of microservices that allow developers to facilitate the full media lifecycle for a digital asset. Using Cloudinary, you are able to programmatically source, manage, collaborate, transform, enrich, personalize, optimize, and deliver digital assets. Each of these microservices are available through a series of REST APIs, SDKs, widgets, add-ons, templates, as well as integrations and out-of-the-box connectors. We support virtually any media format, whether that be images, video, Photoshop files, InDesign files, audio files. We also provide support for 3D, AR, VR, and 360-degree media. With our multi-CDN, Cloudinary is able to deliver digital media to every device, every screen, everywhere. Let's have a look at the first intelligent video feature that we are going to demonstrate today. We call this feature shoppable video. Part of the Cloudinary video player, shoppable video defines a set of products that appear in your videos and display product images alongside the video within a product bar. Users are then able to shop through the video, visit product details pages, or view the product within the video with a single click. Developers can add the shoppable video bar by adding the shoppable parameter to the Cloudinary video player source. The shoppable parameter is an object that contains all of the configuration required for the shoppable video products. Here we can see that we've added the shoppable parameter. And within the shoppable parameter, we can see a products array of product objects. And here is where we specify what events and actions should occur as users interact with the products within the shoppable bar. So in this case here, with the sunglasses product, if a user clicks on this product, the video will skip to the specific time where the sunglasses are featured. Whereas the other products, such as the green dress and the brown bag, will instead redirect users to the ideal product display page or product listing page. Let's see all of this in action. When I click on the sunglasses, note how the video will skip to the point where the sunglasses are featured. And if I choose to click on either the green dress or the brown bag, I will be redirected to the ideal product display page. As you can see here in the shoppable video reference documentation, the shoppable video experience is highly configurable with the ability to configure hover events, on-click events, as well as the ability to pass through arguments for each click event. You're also able to specify when the product bar should be minimized and maximized, as well as what should occur when the video gets replayed. Next up, we'll be looking at our interactive video zoom feature. This new interactive video zooming concept by Cloudinary provides your customers with a new way to interact with your videos. The interactive video zoom-in feature was developed by Cloudinary Labs. Cloudinary Labs is a subdivision of Cloudinary that focuses on experimenting and pushing the boundaries of digital media experiences. Here we can see that the interactive video has been set up for us within a code sandbox, and in this case here, it has been configured as a React application. As I press play on the video, you'll see that there are specific zones that we're able to zoom into. So I might be interested in, saying, having a closer look at the model's shoes. I might be interested in purchasing the shoes. And I'm also able to zoom in closer to the top of the model, as I might be interested in purchasing, say, a top, or getting a closer look at the model's hairstyle. You're able to trigger different events for each of the zones, so it might not always be a zoom. For example, you might want to specify an event that occurs. In this case here, we're seeing that middle click pops up within a console dialog. What the interactive video zoom allows you to do is actually specify the source video files that should be displayed when users click upon a specific region. So for this example here, if the users click within the top zone, they're actually shown an alternative video, which is a zoomed in video of the top of the model. Whereas clicking on the bottom zone lets up a zoomed in video of the bottom of the model. And here we can see the window alert that appears when you click upon the middle zone of the video. While in this use case here, the top and bottom videos are separate videos, it is also possible to use Cloudinary's extremely powerful transformation engine to create those video variants from a source video. As using Cloudinary, you are able to resize and reframe videos. If your video is of a higher enough resolution, you would be able to generate the top and bottom videos from the source video. Next up is video color mapping. Cloudinary has allowed users for quite some time to replace colors within imagery. For example, this blue car here is actually a red car that has been turned blue. So I'm able to replace the red color with any color of my choice. For example, I might want to change the color of the car from red to yellow instead of blue. In this case here, we have a bellet bag with a blue trim. And in this example, when using the replace color function to turn the blue trim of the bag into a maroon color. And as we saw in this previous example, I'm able to target the color that I want to replace and choose any color of my choice. So perhaps I want to change the blue trim to black. As part of Cloudinary's intelligent analysis of your digital media, Cloudinary identifies predominant colors and the top colors that are present within your image. As a result, you don't have to guess the color codes for the colors within the image that you would like to replace. Cloudinary is now taking the amazing replace color feature in images and moving it over to video. This is an incredibly complicated computational task. Thankfully, Cloudinary has been successful by breaking down this task and focusing on 3 video attributes. The first attribute is the context of the video. Here, Cloudinary creates a mask on the video based upon the input color. This mask is then applied to each frame within the video that allows Cloudinary to filter and then isolate the object that is going to have its color updated. Once the object has been isolated, the color value of the object has to be converted from RGB to HSV. This allows Cloudinary to not only take into consideration the raw color, but also the brightness and the saturation of the color within the video. And as a result, the video color mapping is able to preserve detail as well as lighting conditions. Let's take a look at some examples of this video color mapping feature in action. In this example here, the green shirt worn by the walker on the left treadmill is being replaced by the colors of red, purple, and an aqua green. In this example here, the girl wearing the blue outfit is the original video color. And Cloudinary has created a green, purple, and red variant of the video. Here we have a more challenging example where we're dealing with harsher lighting conditions that affect the brightness and the saturation of the color. In particular, the sheen of color on the model's belt is very, very difficult to replace accurately. And just for a bit of fun, as Cloudinary is able to replace the target color with any input color of choice, it is also possible to animate this feature. In this example here, we can see that the actor's top is continually changing color, applying this very, very nice rainbow effect. Let's move on to some media features where Cloudinary has incorporated AI. In this example here, we're seeing a demonstration of AI content aware cropping. This means that from one original source video or image, Cloudinary is able to intelligently crop and resize the image and optimize it for all devices. This ensures a better customer experience across all touchpoints. Let's see a demonstration of this in real time. Here we have an original video showcasing a motorbike. It's shot in a standard landscape aspect ratio. And as you can see that the subjects are moving left to right across the frame throughout the video. It would be a challenge to then have to convert this video into a portrait video without having to do some intelligent reframing of the video. Here we have an example of a portrait version of the video that we just saw that has been generated by Cloudinary. And note how the motorbike stays within the center of the frame. Cloudinary achieves this by using AI and machine learning to essentially detect objects within the video itself. So here, using our really great debug mode, we're able to see how the gravity auto feature is thinking when repositioning the frame of the video and generating the portrait version of the video from the landscape video. We can actually see activity heat maps that indicate where Cloudinary has determined where the gravity of focus should be. This is an extremely valuable feature when working with images, but even more so when it comes to video. Another area where Cloudinary utilizes AI is within background removal. Cloudinary has employed deep learning algorithms to recognize the primary foreground objects within a photo, and then accurately remove the background in a matter of seconds. Here we have a code sandbox where we're displaying images before the background has been removed and then afterwards. So note that the backgrounds of these images here have different lighting attributes, different colors, and also a different subject within the foreground. And here we can see the images after normalization, where all the backgrounds have been replaced by this flat cream color. Whenever AI is used as a part of any solution, there's always the question of the confidence within the artificial intelligence itself. Thankfully, the Cloudinary Media API provides a background removal confidence score whenever the background removal feature is used. As a result, depending upon the confidence score returned, there can be no required action. Say the confidence score is high enough that we can consider the background removal a success. Alternatively, an action could be required where the confidence score is not high enough, and the asset can then be prepared for manual moderation and processing. Let's take a look at a real-time example where we receive a confidence score after removing the background from an image. Here on my local computer, I've got this sample image. And within my code editor, I have a simple Node.js script that's going to upload the image we just saw into Cloudinary using the Upload API. Here we can see that I've specified the file name, but I've also specified a notification URL. So in using webhook.site, we can see the result of any notification events that Cloudinary has broadcasted. We can see here from my upload configuration that I am specifying a background removal, where I've specifically told the Cloudinary AI to use a person object for the foreground object. Heading over to my terminal, I'm going to run the upload.js script. And we can see that we've got a successful response and no errors have been returned. Popping it over to our webhook site, the first initial request has been received, and we can see here that the secondary request has also just come through. So what's happened here is that the first post response is the original upload event, where Cloudinary has received the objects. And here we can see some intelligent tags that have been applied, as well as some image tagging here, and a whole bunch of information from the upload event. The background removal has then run after the initial upload event. We can see here, Cloudinary AI, it's been completed. And we can see that the confidence score returned is 0.806. Now if we go back to my Cloudinary Management Console, I can do a refresh. And the image has been uploaded into Cloudinary with its background removed. We can quickly test this with a background transformation. So I can open up this image within a new tab. And here I can specify a background color of choice. And in this case here, we can see that the background removal has been pretty successful. Let's explore what Cloudinary has to offer in the 3D and augmented reality space. Enabling 3D and AR experiences for web and mobile customers will create new and immersive consumer interactions that will generate greater engagement. Digital 3D visuals are on the rise and have been proven to be valuable, as seen with e-commerce, camera apps, games, and maps. It's becoming more and more clear that 3D and augmented reality media are going to become common forms of digital media. Cloudinary is hard at work simplifying 3D. We've been very successful in the 2D media space and would like to continue being a leader within the 3D space. One of our strategies to achieve this is to apply the same Cloudinary 2D media mechanics to 3D media, providing 3D object management, format transcoding, 3D to 2D, as well as 2D to 3D capabilities, material and texture support, mesh optimization, and support for augmented reality. Let's have a look at a live demonstration of some of these features. Here within this accounts media library, we have some 3D objects that are present. If we have a look at this asset here, while it can be viewed as a 2D image, it is actually the 3D model of a sneaker. When we load a 3D model within the Cloudinary Media Library, we are able to interact with it as one should expect when interacting with a 3D object. We're able to adjust the viewport, as well as adjust the zoom. As mentioned earlier, we support texture and meshing. So what we can do here is select a mesh of choice. So we've highlighted this particular portion of the 3D model. And there we can specify an alternative texture or diffuse map. In this case here, I can apply an alternative cream texture to the 3D model of the sofa. A lot of Cloudinary's success has been on optimization, and we intend to do the same with 3D objects. Let's take an alternative 3D object and have some fun with the optimization feature. So in this case here, we can aggressively optimize down further to, say, a 40% optimized version. And we can see that at 40%, the 3D model is still very much usable, with only minor degradation seen at the bottom of the model, as we can easily inspect using our 3D model object viewer. We can also opt in to view a wireframe of the object, and this clearly shows the triangle count and where triangles have been removed to reduce the complexity of the 3D model. For the consumer, Cloudinary has developed an AR 3D viewer demonstration. In this demonstration here, we can select various 3D models. We've seen the sneaker before. Let's have some fun with this fox model. As we saw previously, we're able to manipulate and move the 3D object around. Here we're also able to play any embedded animations within the 3D object. For example, we can make our fox walk. For the scene here, we can also adjust the lighting of the scene. So it might be that we want to apply some basic lighting, or perhaps some brighter park lighting and outdoor lighting. And we can also apply a skybox just to provide a more immersive viewing experience of the 3D object. The great thing is that this AI demonstration is actually available and online for everyone to try out. So if you'd like, feel free to scan this QR code, follow the prompts, and then have some fun on your mobile device with the Cloudinary AR 3D viewer. You can see here that I'm using the AR 3D viewer within our office, and you're able to use it either landscape or portrait. And I've placed a 3D model of the Cloudinary logo on my work desk, and I can drag and resize and have some fun with the object. While not as interactive and as immersive as the AR 3D viewer that we saw earlier, image modeling with texture mapping can also provide lots of value. Texture and displacement maps can be highly effective for specific use cases, especially for user-generated content scenarios. It might be that you want to allow users to upload their own t-shirt designs, but then realistically more represent the t-shirt designs with the appropriate lighting and saturation applied to the custom uploaded design. We can take a deeper look into this use case with this live example shown here. This live example is actually put together from a series of assets. Here we can see we have an image that is the shirt only. We have the model with the arms and the neck. Here we have our texture map, as well as a displacement map. Putting all of these elements together, we're able to generate this image of the Cloudinary logo and text that has been realistically displaced to match the texture and shape of the shirt. Let's dive into this example using the Cloudinary Media Inspector. This Media Inspector is available as a free tool for Google Chrome. It performs color image analysis and also provides key information about any media that you view quickly and accurately. It's also extremely valuable when working with Cloudinary transformations. And in this example here, we're going to debug this transformation and see how we go from having only a white shirt through to a model wearing a tailored shirt with a custom design. So we see here that our first step is actually to use the shirt for positioning and then apply a logo as our custom graphic on top of the now hidden shirt. We've then applied our text, but note that the image and the text are being displayed as flat imagery. Next up, we've taken that displacement image that we saw earlier. However, it is hidden, but we can see here that the logo and the text are now taking upon the shape of the displacement map. After that, we then add the shirt only as an underlay, and we are applying some color replacement features here, turning the white shirt into a light gray. Next up, we add the model. We then add the texture map with some slight transparency involved. You can see here that if I move the logo down to the bottom of the shirt, that it will adjust according to the displacement map underneath. And this brings us to the conclusion of today's presentation. We hope that you've enjoyed seeing the latest and greatest of what Cloudinary has to offer. Cloudinary simplifies the latest digital media trends and innovations with intelligence and automation and delivers complex media at scale. We do that through our focus on intelligence and automation, media science, agility, and extensibility. We hope that you found this presentation informative and valuable. From everyone here at Cloudinary, we look forward to working with you and helping you unleash the full potential of your digital media. Thank you.